Good morning, students. You are welcome to another class. I believe you are ready with your writing materials, your jotter, your pen, and your textbooks beside you. Please don't be distracted in any way or the other and get set for the class. My name remains Ilesanmi Tokpe. I believe all assignment has been done, and I believe all questions has been treated as regards what we did in the last class. In the last class, we discussed about expansion of brackets, and I think we've done a lot of justice to that. We've solved questions, solved so many problems on that. So this morning we'll be looking at factorization of simple algebraic expressions. It's still under algebraic expressions. Don't forget the meaning of algebraic expressions that we said. Okay, now let's look at the lesson objectives. That is, there's a focus why this lesson is put into play. The first is you are to identify factors in algebraic terms. You are to identify the common factors in two or more algebraic expressions. You are to identify fractions with monomial denominators. We are going to look at what a monomial denominator is all about. Then you must be able to simplify algebraic expressions of fractions with monomial denominators. Then you must be able to expand word problems leading to simple algebraic fractions. Now let's start with factors of algebraic terms. This is just like factors of numbers. And in your prelim class, you've come across factors and multiples, the HCF and the LCM. So we'll be looking at factors of algebraic terms. But before we go on, I want to remind us of this. Can we just write out the factors of 12 and 36? Okay, I think you can list them out for me. I'll put them down. Factors of 12, we have 1, we have 2, 3, 4, 6, and 12. These are the factors of 12. That is the numbers that easily divide 12 without leaving a remainder. So those are the factors of 12. Now let's look at the factors of 36. We have 1, 2, 3, 4, 6, 9, 12, 18, and 36. Because all numbers, they are factors of themselves. Now, similarly, algebraic terms can be expressed in two or more factors. We are going to look at that. This is just factors of numbers, but we are looking at factors of algebraic terms. Now, let's look at this. We want to look for the factors of 12ab and the factors of 36xy. Now, the first thing you're going to note is the factor of 12. Let's put that, the factors of 12. Then the factors of 12a. Also the factors of 12ab. Are you getting me now? Okay. Now let's list out the factors of 12 first. We have 1, 2, 3, 6, okay, 4 rather, 6, and 12. Are you getting me? Now, when you are listing out the factors of 12a, you must list out all the factors of 12 first. Then you now attach a. I don't know, maybe you understand what I'm trying to say. All the factors of 12 will also be all the factors of 12a with other numbers attached with a. Then the same thing goes for 12ab. All the factors of 12, all the factors of 12a, then all the factors of 12ab. Okay, let's start with the listing. 1, 2, 3, 4, 6, 12, a, 2a, 3a, 4a, 6a, 12a. Okay, hope you are following. Then we have AB, 2ab, 3ab, 4ab, 6ab, and 12ab. Correct. Okay, I'm going to give you this as a take home. Pick your pen, pick your jotter, list out all the possible factors of 36xy. Just as we did. We're going to list out all the factors of 36. 1, 2, 3, 4, 6, 9, 12, 18. And you're going to list out the factors of 36x. Stuff like that. Okay, let me just help you, then you do the rest yourself. I'm just helping you, but you do the rest yourself. 1, 2, 3, 4, 6, 9, 12, 18, 36, x, 2x, 3x. List out the rest for me. Okay? Now, the next is we want to write down all the possible factors of 4xy, 6x squared y, 6x squared y, and 4xy. Now, the first thing is we want to write out the expansion of 4xy. How do you do that? By writing out all the factors of 4xy. Let's list them out. We have 1, 2, 4, x, 2x, 4x. We have y, 2y, 4y. Then we have xy, 2xy, 4xy. Okay, I think that's all. Okay, for 6x squared y, let me give you the clue. We have 1, 2, 3, 6. We have x, 2x, 3x, 6x. Then we have x squared, 2x squared, 3x squared, 6x squared. Then you have xy, 2xy, 3xy, 6xy. You can list out the rest. Okay? Now let's move on to the next subtopic, which is highest common factor. Highest common factor. In your prelim class, can someone just tell me what is highest common factor? Okay? I think you have many ideas, from your prelim class. Okay? Now, what is highest common factor? Let's take note. Highest common factor. The first, it must be a factor. Then the next, it must be common. Then also, you will pick out the highest. The first, it must be a factor. Then next, it must be common. You might have 2 or more common factors. Then you will pick out the highest in all. Someone will ask me, sir, but we can have plenty highest. No, it's not. Okay? Now, let's look at this example. We want to find the HCF, the highest common factor, which is the highest common factor of 4a and 6ab. How do you approach that? Just like our normal way of finding the highest common factor of numbers. That is how we are going to do this. Okay, factors of 4a. We have, don't let us list out factors of 4a. Let's just go straight to 1 multiplied by 2 multiplied by 2a. This will give us 4a. Yes or no? Yes. Okay, now for 6ab, 1 multiplied by 3a multiplied by 2b. Then we can have 2a here. Okay, okay, let me do it in a clear way of which we are going to understand better, so that I will not. Now let's list out the factors of 4a. We have 1, 2, 4, a, 2a, and 4a. The factors of 6ab. We have 1, we have 2, we have 3, we have 6, we have a, we have 2a, we have 3a, we have 6a, we have ab, we have 2ab, we have 3ab, and we have 6ab. Are you okay? Now, we will now look at the common factors. Which one is common? 1 is common, 2 is common, 3 is common. Okay, 1 and 2, they are common. Then a, 2a, they are common. Okay, a, 2a, they are common. Then which other one is common? I think that's all. So we are going to pick the highest. Which one is the highest of all? 1, 2, a, 2a. 2a is the highest. So 2a is the factors of, is the highest common factor of, that is the HCF of 4a and 6ab. Okay, let's look at some other examples. We want to find the HCF of 4a square and 6ab square. Okay, the factor, first we are going to look at the factors of 4a square and the factors of 6ab square. Let's just write it here, 4a square, then 6ab square. Okay, now how do we get 4a square? By multiplying 2a multiplied by 2a. How do you get 6ab square? Multiply 2a multiplied by 3ab. 3ab square, rather. Sorry, this is wrong. Okay. That will be 2a multiplied by 3b square. So what is the factor now? That will be 2a. Very simple. Then the next one, we have 12x square y, then 18xy square. So how can you link this up? 12 and 18. The first thing is you look at what is the common factor of 12 and 18 and which one is the highest. Between 12 and 18, we have, okay, let me do that. 12, 18. There are factors 1, 2, 3, 4, 6, and 12. Then we have 1, 2, 3, 6, 9, and 18. So which one is common? 1, 2, 3, 6 is common. But which one is the highest? 6 is the highest. Are you seeing it? So that means 6 will be part of the destiny here. So that will be 6 6x multiplied by 2xy. Then this will be 6x multiplied by 3y squared. So which one is common? 6x. So 6x is the HCF of 12x squared y and 18x y squared. So just try this. Find the HCF of those algebraic expression. Now, the next thing we are looking at is factorization. Factorization is just a way of bringing terms or collecting it in a bracket. I think that's how it is. Look at this. We want to expand. Okay, that is, when you factorize and you try to expand, it's going to give you that same algebraic expression. Look at this. Like this now, we want to factorize 6x plus 2y. First, you look out for the common factors between 6x and 2y, and that will be 2. Okay, that will be 2. So that means that when you factorize, when you bring out 2, the resulting this thing here will be 3x, then this will be y. Okay, let me explain again. Now to do this, we look for the common factor of 6x and 2y, and that is 2. This is for 6x equals what? 2 multiplied by 3x. And 2y is 2 multiplied by y. Yes or no? Yes. Do you see now that 2 is common? Now, hence, 6x plus 2y equals 2 into 3x plus y, which amounts to the reverting expansion process. With examples, we are going to understand what I'm trying to say. Now, let's look at this example. We want to copy and complete this. There are methods that you can use to factorize. There's a particular term inside the bracket. We just denote it by using dash, dash, dash. Later, we use Q to represent that algebraic term that is inside the bracket. Now, how does it come into play? The first thing is you look for the factor. Now, we are having 9xy plus 6y. It's just for you to complete it. They've already bring it out, 3y. So, inside that 3y, because you want to factorize this, you must have another algebraic expression inside the bracket. So that is why we represent it as q. Now, the logic there is that divide both sides by 3y. You are going to get your q. So when you divide both sides by 3y, your q equals 9xy divided by 3x plus 6y divided by 3y. So your y will cancel y. 3 here, that will be 3. Then this will be 2. So what do you have? This is 3x plus 2, which is the term that is here. Do you understand me now? Okay, let's look at some other example again. We have that we have to factorize 9p plus 18pg. Now, you look for the common factor. What is common to 9p and 18pg is 9. So you just bring out, let's use that method. Since we already have, that will be 9p plus 18pg equals 9p into q, because we don't know. Now, let's use that method. Let's divide both sides by 9p to get your resulting q, which is the algebraic term. So that will be 9p divided by 9p, then plus 18pg divided by 9p. This will cancel out. This p will cancel out. Then you have this. So that means q equals 2g plus 1. So which is so that means in place of q, this is what you put there, 2g plus 1. Do you understand me now? Okay, let's look at the second one. We have that the highest common factor is 3q. I'm talking about the second example now. That will be 12pq minus 9q squared. So you already have the common distance to be 3q. So you just put it q, which is the unknown. So do this for me. Find q. Just divide through by 3q. So, and you are going to have your q. Now, we want to factorize the following expressions. How do we start? How do we start our factorization? Now, what is common here? 2. Okay, 4. 4 can go here, 4 can go here. We have 4 into 2x plus y. That's all. Then, what is common here? 3mn. 3mn. This is 1 minus 2p. That's all. Then this one, what is common here? xy. That will be 1 plus z. That's all. Now, this is another one again. Okay. You check what is common. There's x here, there's x here. So that means x is common. You bring out that x. That will be 2y minus az. Then this one, you check what is common. What is common? Y plus 1 and 1 plus y is the same thing. So that is what is common. That will be 1 plus y. Either you write 1 plus y or y plus 1. That will be x plus y. Then this. What is common here? Minus 6uv is common. Minus 6uv. So this will be 2 minus r. Is it minus or plus? Plus r. Because when you bring it out. So when you open the bracket, it will give you back this. Try to open up the bracket. Try to open up those brackets. I've taught you expansion of brackets. So you can try it and you see that it will give you the resulting this. So try this. Now we move on to algebraic expressions of fractions with monomial denominators. Someone will ask me, what is the meaning of monomial denominators? Monomial denominators is just any algebraic expressions that has only one term in the denominator. For example, if you have xy over 2q, this is having just one term. So this is called a monomial denominator. But if you have xy plus x plus y, this is not a monomial denominator. This is not a monomial denominator. This is more than one. Mono means one. Monomial. Mono means one. That is, you must have only a single term in the denominator. Now let's look at this example. Which of the following is a fraction with monomial expression? You can have it monomial expression or monomial denominator. You will look at b. b is not a monomial expression. Then which one again? G is not a monomial expression. So, but the rest, A, C, D, E, F, because they have only one single term in the denominator. Now, we move on to how to simplify monomial denominator. How do we simplify a monomial denominator? It's just our normal simplification. You know, we have x over 3 plus x over 5. What you just do is just to find the LCM. What is the LCM of 3 and 5? 15. So 15 in 3, that will be 5, multiplied by x, that is 5x, plus 15 in 5, that will be 3, multiplied by x, that is 3x. And that will give us 8x over 15. So 8x over 15. Then the next one, 2 over p plus 3 over p. You have 2 over p plus 3 over p. What's the LCM? P. So p here 1, p here 2, then this one is 3, that will be 5 over p. Very simple. Okay, let's look at this other one. We have we have 3x over 5 minus 2y over 7. What is the LCM? 35. This will be 21x minus, this will be 5 minus 10y. So this is x, this is y. You can't do anything. You just leave it like that. The next one, 7x plus 1 over y minus 3a over xy. So what is the LCM? The LCM is xy. So we just multiply x with this. That will be 7x squared plus x minus 3a. That will be your answer. Okay, just try this and get back to me. Now, okay, so try this. I think we've come to the end of the class and we've done factorization of algebraic expressions. And the last thing is word problem leading to algebraic expressions. And that would be, okay, let me explain that. Look at this example. We are to find the area of a rectangle whose sides are this. This is a rectangle. The side is x plus y, then x minus y. I think I've taught you this in our last class. I think last class we did something like this. So, if you are finding the area, what is the area of a rectangle? Length times what? Breadth. So that is x plus y multiplied by x minus y. So this is under expansion of brackets. And this will give you x squared minus y squared. So I believe you understand the class. So thank you very much for listening. Bye.